This is the recording of the kickoff web seminar from the event series natureplus Europe Healthy Buildings 2020. The topic is Indoor Air Quality, Understanding, Ensuring and Realizing Healthy Living.
Welcome everyone to the event series natureplus Europe Healthy Buildings 2020. My name is Tilman Kramulisch and I may welcome you as the director of the natureplus Association. Yes, well, in times of Corona, we spend more time than ever indoor. I think you also know that, or we will spend a lot of time indoor, I guess. And however, there's little discussion about the role of buildings for the human health, which are often anything but healthy. So the idea of this event series was that we want to raise awareness about the topic and exchange knowledge about key factors, materials, and best practices. So it's a pleasure to have you all here today, and many thanks for joining this European-wide compilation of expert events about on healthy living and people. We are often offering these events together with our partners of the ASBP from the UK, Acrodome, Stichting, IBO from Austria, and also EOS from Belgium. And also many thanks I want to say to our sponsors, the manufacturers Baumit and Lignogent, for their kind support. So today we will start with a sophisticated introduction with very interesting experts and into this topic, introduction into this topic. So after our after work session today deals with indoor air quality and the question of understanding, ensuring and realizing healthy living. So I go to the next slide. Maybe Katerina, you can help me.
Sure.
Thank you very much. So before we start, very shortly, let me introduce what we do as natureplus. So natureplus is the International Association for Sustainable Building and Living. We are a non-profit environmental organization, member-based network, and we are working and engaging for sustainable building sector, and we are convinced that for climate-friendly, resource-efficient and healthy buildings, the material we choose are key. So let's have a look at the next slide. So our network is European-wide. As you can see, together with our European partners, we are offering this event and a lot of more. And our members, they are from all relevant sectors of the construction field. So if you go to the next slide, you can see that we are following a comprehensive approach to sustainability, and we think that climate protection, healthy accommodation, and sustainable use of resources is all connected. We do many different activities. Many of you may know the natureplus Eco label, for example. We do lobbying and campaigns, webinars, of course, and you're very invited to have a look on our natureplus database where you can see all the certified products, and also on the homepage other services and so on. So we are very interested in new members. So if you want to get involved, you're very invited. Also, you can subscribe our newsletter, engage in different aspects. And if you have any question, don't hesitate to contact us. And now I'm going to hand over to Katerina, and she will guide us today through the web seminar. Thank you.
Yeah, hello. Thank you, Tilman. Hey, everyone. My name is Katrina Brenner, and I'm very happy to be your host today. I'm going to lead you through the agenda, through the program. And before we get to our 3 presentations today, I have a few technical and organizational issues to just inform you about. So first, a quick introduction into the most important features of Zoom here that will help you to interact with us. And we're always happy about interaction, about comments and questions. First of all, if you click on participants down here at the bottom of your window, you can see all the other participants, so you can see who else is joining the session today, which might be interesting for you. And then also this little feature here, the little hand in the corner, that indicates that, like, if you click on that, you raise your hand virtually, digitally, and it'll let us know that you would like to say something and that you would like to speak. So please use this later on in the Q&A session if you would like to say something, because then we can unmute you. As Tilman said in the very beginning, for now everyone is muted. That helps us to reduce background noises considerably. But if you would like to speak, you can just raise your hand here on participants and then the bottom left corner there. The other thing you can use is the chat function. So please feel free to contribute your comments or also ask questions in the chat. We will monitor the chat and then bring in your questions in the end of this web seminar today. We will collect them here. So please feel free to use it. Just take a look here at your drop down to see who you're sending it to. Just make sure you're sending it to all. And that means everybody can read it, and usually this is what you want. So sometimes the drop down might be set to just a specific person, and then all the others wouldn't be able to see your comment. So just check here. Also, please switch off your video. Tilman has mentioned that already as well. It's just quite important for our connection and for our broadcasting, so we won't have any delays. And then one last organizational thing, you will receive all presentations afterwards, after the web seminar series has been finished. And also this session is being recorded, and we will make the recording available to you as well, just so you know. Now, what are we doing today? Yeah, the opening and the moderation, the organizational part is done already, yay. And we are looking forward to 3 presentations. We have Dr. Rolf Buschmann with us, we have Vanessa Laumann and Andrea Klinge, and we will do the Q&A, the discussion round at the very end of these presentations. So please hold off with your questions until then, or post them into the chat if you want to store them somewhere or if you want to place them already. All right. But yeah, before we head into the presentations, we have one quick question for you, because we would like to get to know our audience a little bit. And it's a very quick one. It's a little poll. I hope you can see it. And we would like to know in which area of construction are you active? So what's your professional background? Is it construction planning? Is it project management, government agency, real estate, NGO, or manufacturer? I apologize if we didn't hit your particular realm, but we tried to give some variety here. So yeah, I can see that lots of people are clicking their answers. And I'll give you just a second to do so too. That's just interesting for us to see who our audience today is. Okay, I think everyone who wanted to participate did so. So I will show you the result. So lots of people are from NGOs. We have some construction planning, some project management. But yeah, as you can see, NGOs is our focus today. So thank you for participating. I think this gives us a little bit of an impression of who joined this session today. Thank you. Okay. And with this, I'm very happy to introduce to you our first speaker today, Dr. Rolf Buschmann. He has been working for the German Federal Environment Agency since 2013.
No, I'm not with the Environmental Agency. I'm with Bund für Umwelt und Naturschutz. I'm member of the Indoor Air Quality Hygiene Commission of the Environmental Agency. That's something different. I'm not working for them. I'm just.
I'm sorry. Okay. Thanks for setting that straight. I'm very sorry, Dr. Bushman. But what I do know for sure is that he is the natureplus president and advises the natureplus management, particularly on strategic issues. So I hope I got that right. But and in any case, he will kick off our presentations today with his topic, understanding healthy living. And I will hand over the remote control.
Thank you.
To you now, Dr. Bushman.
Okay, fine.
And yeah, thanks for being here. And there you go. I think it should be working now.
Yeah, lovely. Thank you. So my task is to give some impressions on what indoor air quality means and where does it come from, the idea dealing with indoor air quality. And as mentioned, the Indoor Air Quality Commission of the Environmental Agency is a consulting commission which consults the Environmental Agency, and I'm one member of it, and there are other experts members to that commission. So understanding indoor air quality. Indoor air quality is something which we deal with, I think, since mankind is on Earth somehow, even when we sat in the Stone Age somewhere and had fires burning, it had influence on our housings. So it's still a question today how what impact we do have on our indoor air quality, because it's important. About more than 20 hours a day we are spending indoors, and mainly in our own environmental living rooms. And so it's very important that we find ways to keep that clean and in a perfect and usable way. So I can't move forward yet, so doesn't work. Sorry.
All right. Do you want me to forward?
Yes, please. If you can do it, I can't do it.
Of course, no problem.
Okay, so the history of scientific approaches to indoor air quality is much longer than just our century. So it started about 1750 with a first essay on concerning effects of air on human bodies. And here we have a citation of Max von Pettenkofer. He is the founder of the famous von Pettenkofer Institute, which is the hygienic institute in Germany. And as a chemist, as I am too, he was the first professor on hygiene in Germany. And he said, air can be impure in two ways. It can contain foreign substances, which are detrimental to us in their quality. And it can contain the normal components in an abnormal mixing ratio. So we know that looking at CO2, indoor air quality is very often driven to too high CO2 concentration, which hinders us in concentration and is hindering to our quality of work sometimes. Next slide, please. And he made another comment, and he said, we should proceed more rationally if we prevent from the start on the release of such foreign substances into air, instead of trying to eliminate them or the consequences of these substances just by powerful ventilation, doing more ventilation on that. So next slide, please. And one perfect goal, what do we need indoor air was given to us with Adolf Behne. He's an architect, by Bauhaus architect. And he said, we don't want anything less than our home keeping us healthy, fresh and cheerful with a minimum of pollution and a maximum of comfort. I think this puts it in the right way of looking at it. So we don't want to have pollution in our homes. So what kinds of pollutions can be in our rooms? So main factors for the lack of indoor air quality can be chemicals. These are mostly volatile organic compounds. We have many lightly volatile organic compounds coming from paints and varnishes, for example. But we do also have suspended particles as dust, and we all know that particulate matter coming from streets and from cars and from fire stoves are a problem too. Radon is something which we do have in Germany, especially in certain areas, and it comes from mainly natural sources out of the earth. Microbes can be a problem, bacteria, of course, viruses, we all know that at the moment, and this is driving us very hard, but mold is another thing which can be indoors as well. Pets and pests, of course, we do have pets, and we have pests being a main source of allergens. Temperature, humidity are driving forces to increase the release of chemicals or the release of chemicals out of building materials. And if humidity is too high, we can have growth of mold as well. Ventilation will be something which is the most important driver. If it is insufficient, we will have an increase on all factors of substances which are not good for indoor air quality. Next slide, please. So what is going to be done to increase a good indoor air quality? So we will have to identify building materials and substances and interiors which are good for a healthy indoor air quality. We need to identify them, we need to have appropriate information on the contents of these products. We need to know what is inside a product in a furniture, but also in the building material to know whether it can harm our indoor air quality. Instructions have to be taken on measures, how to apply substances and use the products. And we need to ensure that during construction, modernization, or refurbishment, well-trained and experienced craftsmen are dealing with that. Due to my knowledge and due to my work I've done, I worked for a consumer agency in the past. We always had problems with people coming to this organization saying, okay, there were painters in our house, and afterwards we have problems with our indoor air quality. So applying the product in a right and good way needs well-trained and experienced craftsmen. So I'm sure due to the better insulation of our homes, we need to ensure a good ventilation. We heard that especially in the Corona crisis as well. Even now, getting to winter times, we need to have a better ventilation of our homes and of indoors because the virus will be less available if we do have a better ventilation. And of course, residents and users and people using homes have to be trained how to deal with a good ventilation and how to deal with the product they are using. Next slide, please. Reality bites, what do we have? And actually, we always find polluting building products. We still have non-identified smells making people conscious about something is wrong in my own home. We do find proved contaminations in homes, in working places. And of course, due to these contaminations, there will be health risks. And we still find inadequate product information so that people misuse products in a wrong way. And we have the lack of knowledge in the use of products. I spoke of the well-trained craftsmen. Not always we do have these. And of course, in the end, we have the citizens and the users of the homes which haven't got the right information to deal properly in their own homes. Next slide, please. So what is building products and proper solution? We will see that depending on what kind of product you apply, there is a higher rate or a higher probability of having high emissions. So the bigger the surface is and the more you have chemicals inside, the more probable can be a solution, pollution. So textile floor covers have been, and paints and varnishes have been the most relevant indoor air quality problematic substances. Next slide, please. So what about smells? People mostly identify that something is wrong in their house by having a kind of unidentified smell, something which is smells, and chemical smells are always combined with the idea that might be dangerous. natural smells are healthy is an idea that people think it's not always the same in that way. But what we all know is that smells can influence the well-being. Smells are the reason for rejection of products and the rejection of what being staying in a certain room. And smells are, of course, and that's something which we learned as human beings for a long time, smells are mostly signals for danger. So, but what we should know that initial smells in the building environment are to some extent unavoidable, and that means that we need to have certain times to ensure that smells can go down before we have a constant living in that rooms. Olfactory pollution is recognized today as an important matter. Next slide, please. This is an example which is a bit older. I found this in one of my old slides, but I think this is something which shows very good that due to the use of inappropriate building materials in indoor environment, you will have high emissions. So this was a living area for a family which had high emissions of volatile organic compounds, and this was due to the misuse of a solvent-based bitumen coating in indoor environment. This was probably this should have been used outside, but not indoors. And this is something we often find that due to the inappropriate use of building materials, we have a contamination of indoor environment. Next slide, please. So health risks are always, according to health risks are combined with inconvenient smells. They cause sometimes non-specific symptoms, so that because of the smell or because the people are not feeling well, they get headaches, nausea, drowsiness, or they have irritation of the mucous membranes. Allergic reactions are caused by biocides, for example, but also of other products. Long-term effects are seldom, but if they are always, they're mostly addicted with biocides and flame retardants in the past, because flame retardants are mostly chlorinated or brominated substances which are toxic. And the problem of fear is mostly something which people have if they find something inconvenient in their own homes. Fear is a main driver of a health problem. Next slide, please. During the use of building products, we do have certain factors which, of course, provide kind of pressure on using inferior quality products. So cost pressure is something which might lead to indoor air quality losses because the wrong products are used. Time pressure, failures in construction might release substances, and of course that the residents are not dealing well with the new environment. So if the rooms are insulated better, you have to have more ventilation methods to do that. So what we need is kind of binding standards for indoor air quality related to the health environment, and to give that in the contracts of the workers as well. Next slide, please. Product information is something which is very important. So we need adequate product information so that indoor air quality problems will not appear. Safety data sheets are normally not suitable for risk assessments because the people don't understand them. So what the main thing is, producers and retailers need to provide precise, comprehensible, and action-oriented information to ensure health and environmental protection. Next slide. So what is needed to improve indoor air? We need comprehensive range of low-emitting building products. We need target group-oriented information on risk of indoor pollutants and appropriate avoiding measures. And this might be or is one step ahead, is to have a good environmental quality label, which, next slide, please, will have a combination of good quality aspects, will have obligatory qualities, will have an easy access to criteria and to the criteria of the awarding scheme, will have reviewable and transparent criteria, will have regular verification of the users of the label and the products they provide, and will have a continuous improvement on the criteria used for this quality label. Next slide, please.
Yeah, and you got 5 minutes left.
Yeah, but I'm shortly before finishing my talk.
Beautiful.
And this, so naturally, I will say that I think natureplus is one of these labels doing that, giving a convenient approach to transparency, product quality, finding products suitable for daily use, and which are, of course, available on the market. So next slide, please. And this is, thank you for the attention. So I hurried a bit, maybe too much.
No worries. Thank you very much, Dr. Buschmann, for your comprehensive overview of what healthy living means and what it includes. So now, before we head into our other two presentations, there's one more thing we would like to know from you, from the audience. So if you'd like to participate, we have a question for you. Now, this time it works a bit different. The question is, now, what is your top priority aspect to ensure health indoor air quality? So in your daily work, business, in your area of expertise, what is what do you consider priority concerning this topic, indoor air quality? And if you would like to participate and contribute your opinion, you click on the link www.menti.com that Tilman just posted into the chat. So just open that one. And then you use the code that he also just posted, and you can type in your answer. I would just like to ask you to be very brief, because we are creating a word cloud. So just use keywords, no full sentences, please. And I will give you a minute to do that. And very much looking forward to the results. For everyone. So if you'd like, you can actually follow this live. As our word cloud is developing. Yeah, just another moment in case anybody else would like to participate. Let's take a minute to log in. It looks very good. All right. Okay. I think that's it for the moment. Feel free to just still participate. We will download the results later on and include it in the presentation that you will get afterwards. So, but as you see, there is a lot of different aspects like ventilation, biocides, materials, yeah, healthy materials, healthy products. So you can see materials are a big topic, but also source control, which is interesting. Yeah, so thank you. That's a nice overview of what's important to you. And we're back for our presentations. Next one will be Vanessa Laumann. She will present her screen herself very shortly, but let me just tell you a few words about her. Vanessa Laumann is a chemist and environmental scientist and has been working for, excuse me, has been working for Eco Institute Germany since 2013. And as a project manager, she's responsible for product testing and works closely with manufacturers, for example, performing audits for the German ÜMARK certification, as well as natureplus and the Eco Institute label. And on top of that, she's been the head of certification body since last year, leading the development of the Eco Institute label certification program. Thank you for being here today, Mrs. Laumann, and sharing your thoughts on the topic, ensuring indoor air quality. And yeah, we see your screen and feel free to proceed. You might be still muted.
Okay.
There you go.
No, okay. Thank you very much for the introduction. Yeah, just see if I can. Yeah, okay. Pollutants in the air have an immediate impact on health, as we already have learned. So the quality of indoor air is of great importance, especially when people spend in Corona times maybe more than 90% of their times indoors. Yeah, in the previous presentation, we learned already that a major source of indoor air pollutants are building products like paints and flooring and furniture. And a major class of indoor air pollutants are volatile organic compounds. Chemicals, for example, like formaldehyde, that can emit from building products. In this presentation, I like to give an overview on product emission requirements in Europe and also in France, Belgium, and Germany. So how are VOCs regulated? And in the second part, I'd like to explain how the product emission testing works. So how do we measure indoor air pollution? A large number of countries have regulations and voluntary labels to protect us from harmful product emissions and to improve indoor air quality. The European Construction Product Regulation aims to remove barriers to trade within Europe and also sets requirements regarding safety. It lays down basic requirements for construction works. Construction works must be built in such a way that they will not threaten health. In particular, emissions of dangerous substances and volatile organic compounds are mentioned. But the regulation is merely a basic framework. The technical details for construction products are elaborated in harmonized technical specifications. Here's an example. The 14041 lays down the requirements for wood flooring products. This is the basis for CE marking for flooring products in this case. For CE marking, the manufacturer always has to declare the essential characteristics in a declaration of performance. This is an example here from a manufacturer. The CE marking is in most cases a manufacturer's declaration that the product meets EU standards for health, safety, and environmental protection. Only in some cases, assessment of a notified body is required. When it comes to emission requirements for wood flooring products, there is only one limit value for formaldehyde that must be met and declared. The performance of other VOCs cannot be declared here. So there's a gap in the CE marking standard. The declaration of performance for CE marking does not integrate health and environmental protection adequately. The declaration of comprehensive VOC emission performance is missing. But since several years, almost all EU countries are keen to get performance classes for indoor air emissions derived from harmonized reference values. For different products to be comparable, the VOC emission performance must be based on the same testing procedure. In January 2018, so recently, a harmonized European method for the testing of emissions of volatile organic compounds from construction products in indoor air has become available. The name is DIN EN 16516. And a recognized number of testing laboratories are already in place. So a harmonized testing method for evaluation of VOC emissions is available and is planned to be adapted within the harmonized standards of CE marking. But what is still missing in the CE marking and the corresponding declaration of performance is the definition of a common declaration format for VOC emissions. The European Commission is currently working on a new classification system for rating of results of emission tests. It still has been to be decided whether the manufacturer need to allocate the emission results to classes. Here, that was a draft, an example, or just specify single values. But it has not been decided yet on it. So still, there's a gap in the CE marking standard. But 3 countries, Germany, France, and Belgium, already have VOC regulations in place. These already refer to the test method EN 16516. Additionally, several voluntary eco-labels are already refer to the test method, but requirements and limit values differ substantially. Germany was one of the first to limit the amount of chemicals that can be released from products. Laboratory tests have to be performed according to the European emission testing method, and the so-called AGBB scheme sets the limit values. Here's a list of certain limit values. For example, the sum of VOCs has a limit values, as well as the sum of semi-volatile limit value organic compounds. Formaldehyde has a limit value, and cancerogenic substances are limited. Just examples. Some product types require an external audit, additionally, of the factory, and a sample is taken in order to control VOC emissions. These products need to be labeled with the U mark. The French regulation is a labeling scheme from A to C. A limit is set for the total amount of VOC. You can see it in the table. And in addition, just only 10 single substances are evaluated. Products to be traded in France need to be labeled by the manufacturer with the emission classification. Here you can see class A. The third VOC regulation in Europe became mandatorily effective in 2015 for products to be traded in the Belgian market. Emissions are evaluated after 28 days, and the evaluation is similar to the German HB2020 scheme. In comparison, the natureplus VOC emission guideline set limit values for a long list of substances and substance classes. Don't be frightened. In addition to the German HB requirements, for example, there are limit values for individual substances derived from indoor air guide values. These here. These are established by a scientific working group in Germany. Another example is the limit value for formaldehyde, which is much lower than legally required. So here comes the second part. How do we measure indoor air pollution? And especially, how do we measure emissions of volatile organic compounds from construction products in indoor air according to the European standard? At the Eco Institute in Cologne, we have 120 test chambers from stainless steel and glass. Most chambers have a volume of 125 liters. But we operate also larger chambers up to 20 cubic meters for large items, such as furniture. In the test standard, a reference room with a volume of 30 cubic meters is defined. The floor, for example, has an area of 12 square meter. The test specimen must be representative of the product to be tested. So what happens when a flooring product comes to the laboratory for analysis? A test specimen is prepared and placed in the test chamber. Here's a picture, and that's the model. The size of the test sample realigns to the size of the material in the reference room. In order to simulate a model room, all chambers are fed with air that is cleaned of all impurities and maintained at a standard temperature and humidity. The emissions from a product will change over time. Typically, a test run is 28 days. There are two measurement time points. After 3 and 28 days, air is collected on the sampling tube that absorb then the volatile organic substances. Chromatography analysis separate the collected substances. A gas, for example helium, carries the mixture of substances through the thermal desorber and afterwards through the separating column of the gas chromatograph. In the heated separating column, the VOCs are separated. Some migrate faster, some slower through the column. The column is a thin tube up to 100 meters made of coated glass fiber. Mass spectrometers identify the name of each substance. Validation and quantification is carried out by our analysts. Test reports provide a summary of test results. You get a list of individual substances with their indoor air concentration. Reports can also declare compliance with standards like the French, Belgium, or German regulation I talked before, or voluntary labels like natureplus. So with this, I like to conclude. So how do we ensure indoor air quality was the question. Product emissions testing, according to the European test method, provides information on the VOC emission performance of construction products. 3 countries have already regulations in place based on this test method. And the method is already the basis for a number of quality labels. And finally, the test method will be adapted within the harmonized standards of CE marking in the future. This helps to ensure healthy indoor air. Thank you very much.
Thank you very much, Mrs. Laumann. Thanks for this insight into the fascinating world of norms and testing and how you actually, test all these, abstract things and regulations. Thank you. All right, now, relax, audience. I don't have any more exercises for you or questions for you. We will head right into our next presentation, and I don't even have to share my own screen because Andrea Klinge is going to do that for you with her slides. So Andrea Klinge is Head of Research at ZRS Architekten Ingenieure Berlin, and she brings in a planner's perspective into today's session. She's an expert of sustainable building materials and circular economy, and just recently her EU research project RE4, which is a cooperation between ZRS and 12 European partners, won the sustainability challenge of the German Sustainable Building Council in the category research. Congratulations, Andrea, and now we're looking forward to your topic, realizing healthy buildings.
Thank you very much for the very nice introduction. I'm very happy that I can contribute to this very interesting series as well. Maybe just a few words to our office, about our office. We are a Berlin-based practice consisting of architects and engineers. We're working also in the field of research, as you heard. The specific thing is probably that we started from the beginning to work with natural building materials because we believe that they contribute very much to sustainable architecture, but also to a healthy indoor environment. And what is maybe special for our office is that we have our own laboratory where we investigate mainly earthen building materials, but also other natural building materials. This is a quotation from Marta Wisniewska from the Cornell University, homes where the toxins are, that came through just a couple of days ago, because we were asked to contribute to another series in the US where they also deal with the same topic. And the quotation made me smile in a way, but it's also obviously quite sad that we still have to address this issue, and that we still experience difficulties with unhealthy building materials and indoor environmental quality. I'm going to talk today a little bit about the research we did in this field. It's a European research project dedicated to the improvement of the indoor environmental quality in buildings, because the European Commission understood in 2013 that we have severe challenges to overcome. And the other part will be that I bring in a few examples where we as architects have dealt with or how we address the question of constructing healthy buildings. The HOS project was quite a large-scale project, and the topics I want to talk about today relate to relative humidity levels, as Dr. Buschmann stated already earlier, contribute to healthy buildings, low-emitting materials, and what we investigated as well is building materials that might be able to actually absorb pollutants from the air. So the challenges we see as architects is that due to improved energy efficiency standards nowadays, which are detrimental in order to safeguard our planet, we have unforeseen problems, or we have more problems with VOCs, harmful substances, microbiomes in our buildings because of the very high airtight levels. The other issue that we were facing was that humidity levels indoors raised, but also airborne pollutants. So the reaction of the industry was actually to introduce mechanical ventilation with heat recovery in order to improve the indoor environmental quality. And this is where our expertise kicks in. We think that this mechanical ventilation, in certain cases, it is required, but we see it also very critical because it dries out our spaces. We have made measurements that are going to show you also from one of our projects, and other scientists have examined the same phenomena in combination with lightweight construction, or if you don't use the right materials in wintertime in a cold climate, you bring in 24/7 really dry air, and this is what dries the spaces out. The other issues are you need obviously space and cost for mechanical ventilation, and another topic is the very low hygienic standards of mechanical ventilation systems. Just to explain this issue of relative humidity levels a little bit further, there's studies out from Schofield and Sterling that were undertaken already in 1985, and they examined the interaction of microbiomes at different relative humidity levels. So basically what we have in our air is we have bacteria, viruses, fungi, mites, and so forth. And we can't avoid this. And at the end of the day, we shouldn't, because it's important that these are in balance. So we have good microbiomes and we have bad. And as soon as we interfere and start to clean everything with chemicals and so on, we really disturb this environment. The other issue that we see is that, and as you can see in the graph, if the relative humidity levels either drop or are getting too high, you have a higher activity. So basically what we're looking for is a comfortable climate, a healthy climate of relative humidity level that ranges between 40 and 60%. And that's not always easy to achieve. So to show you a little bit about the research project, actually, we did a lot of investigation of earthen materials, but also other natural building materials. We focused very much on internal partition walls. So we looked at every single layer that we need for constructing such walls. So the finishing layers, paints and plasters, dry lining boards like earth dry boards or cellulose boards, or it could be wood fiber based boards. We also looked at insulations, either to be used as internal insulation or as external insulation. And we looked at different products on the market that are modern products for internal partition walls if you avoid the classical stud construction system like these wood fiber flax board or straw boards that you just bring in as a single board and that form the wall itself and will be plastered. What we did as well, but just with a few samples, we investigated also solid timber products like plywood and KVH products or cross-laminated timber, for instance. But this was just a smaller part of the project. So what we did was we did emission testing because we obviously wanted to understand what are healthy or low emitting building materials. And we did at the beginning, which was, sorry, I have to mention this was carried out by one of the project partners, the Federal Institute for Material Research and Testing. They are also based in Berlin, and we had a very close collaboration. So what they did was they tested single materials up front as so-called screening emission tests through the means of gas chromatography, as Vanessa Laumann was explaining earlier, just to investigate what kind of emissions do we have to look for. And then we did larger scale tests. Unfortunately, we didn't have the European test room available, but this is a test chamber for one specimen, and it contains a fraction of this European testing chamber. And then we investigated VOCs, semi-volatile organic compounds, radon, and also formaldehyde. The other issue that I explained earlier, we were also looking into the absorption of harmful substances. And you can see here two different samples. This is the measurement of an earthen plaster, and we spiked the air with different VOCs, as you can see in the legend. So we have pentanol, hexanal, butyl acetate, A-pinene and N-decane, which were set by the Federal Institute because they said these are the main VOCs that we come across in our buildings. So it would be interesting to understand what the materials could do in terms of absorption. And this is in comparison was an entire wall build up of 72.75 millimeters thickness. So we built a wall built up on the basis of a gypsum fiber board that was designed by the manufacturer to absorb VOCs. And as you can see in both materials, there is an absorption. So far, it's just a quantitative figure, and we don't really know how to translate this into our building design yet. But this is just sort of like an initial starting point that we investigated in the project. And what is interesting is, what I find is that we can see here for this earthen plaster with a thickness of 5 millimeters, it has quite a high absorption rate in comparison to this other wall build up. If you compare the finishing layer is nearly 3 times as thick. So this is, for us, was quite an interesting and good result because we like to work with earthen building materials. So this is something that contributes to the improvement of the indoor environmental quality. So the other issue that we looked at was the so-called water vapor sorption capacity of building materials, which means that building materials have a capillary system, and they are able to adsorb and desorb water, but the capacity of materials differs significantly. And this is just a sort of like a graphical illustration that shows the principle. On the top row, you can see an earthen plaster with a capillary system, and on the bottom row, you can see a cement-based plaster. And the blue dots indicate always the moisture that is in the air. And what we see here is already that for the earthen plaster, we have less moisture in the air, but more moisture in the capillary system, because the surface of the earthen plaster is extremely large, which enables the material to adsorb water. And the other issue, or the other benefit that earthen materials have, they contain so-called three-layered clay minerals that were indicated here, that are in addition able to absorb moisture. So this is something we use as practice, as a performance, to reduce mechanical ventilation and to generate really stable relative humidity levels in our buildings. We've investigated this also during the course of the project with measurements, water vapor sorption measurements according to the DIN standard for earthen building materials. And we investigated single materials, the materials that are presented earlier, so the plasters, the insulation layers, the wall lining layers, but also entire wall build-ups. And just to give you a quick summary out of the measurements, the wall build-ups containing hygroscopic natural building materials like earthen plasters, wood fiber boards, wood fiber insulations, absorb really up to 5 times more moisture in comparison to standard gypsum fiber products, for instance. So this is basically just a brief overview what we measured or what we investigated in the HOS project, and this forms actually the basis of our planning work in the architectural department. So what we start with is that we select low-emitting construction materials. There are always some form of emissions, you can't avoid that, but there are very, very good products that emit really just a little bit. And this was also the result out of our measurements in HOS. Sorry, I think I forgot to mention this, that the emission measurements of all single materials and all wall samples were very, very good. We had only one wall built up where the threshold value was too high. And this was down to a glue that was used in this specific wall build-up. So I think this was mentioned earlier. Glues are always a critical material. You have to be very careful with the selection in order to find a product that is really low emitting. And the certification schemes that are very good for this, who did a lot of work for us as architects, are obviously natureplus. And also the Blue Angel, they did really intensive investigations, and if you specify products that are certified by these two labels, then you can be sure that you are below the threshold values. And the other source for VOC declaration in Germany are now EPDs. Since 2019, they should contain a declaration for relevant products for the interior fit out. that might emit harmful substances. The other issue that we consider in our design always is the selection of hygroscopic materials like earthen materials, timber, wood fibers. We also like chalk or lime plaster. And if cost is an issue, I think Dr. Buschmann mentioned this, sometimes you have to specify not the most expensive product, then gypsum fiber boards also are very good in terms of water vapor absorption. And as I explained,
5 minutes, sorry.
If you can introduce earthen materials that are able to absorb harmful substances, then even better. Right, so our projects quickly. This is an extension of a former wash house constructed in the GDR, as you can see on the left-hand side. It's a single layer masonry construction plastered with a chalk salmon plaster, and we were commissioned to renovate the building itself, but also to extend it. And what we did was, this is quite an old project, so we had only a partially prefabrication in terms of the building envelope that was constructed in timber, but that was the standard at the time. Nowadays, you would bring in a fully prefabricated panel, but we used like a timber construction with OSB board as a stiffening layer, and we had cellulose insulation due to fire protection, and to the inside we were using substrates in order to be able to plaster the walls, but also the ceiling with earthen plaster. So this is, for instance, an extended metal substrate, and this is a reed mat that are very suitable for the earthen plaster. This is a picture from the construction site where you can see the finalized earthen finishes. Here again, we used timber windowsills that were only oiled, aluminium timber windows, again only oiled. So the performance, the vapor performance of the timber remains. And this is then the final flat, for instance, at ground floor level, where you can see the nice and modern construction materials. The house contains also apartments and studios, so single room studios, and all different apartments are naturally ventilated. And this is an extract from a monitoring that we installed in the building. On the top, you can see the measurements from the flat I just presented. And in comparison, we did measurements at the same time in another building where mechanical ventilation was installed. And you can see the difference are highlighted here in orange. This is actually the relative humidity level where we would like our rooms to range. And what you can see here in the other building, that the relative humidity level, they drop quite significantly due to the fact that measurements were taken in wintertime. As I explained earlier, you bring in the dry air and you're not able to keep healthy relative humidity levels. Whereas here, this room was slightly too high. This was the bathroom. We informed the client, and other measurements showed now that they range always between 40 and 60%. This is another project. It's an old peat barn that was refurbished. Again, we worked with timber construction, so we have the old structure, but we integrated a modern building in that. And again, we used earthen materials also for the interior walls as insulation material, because we wanted to improve also the performance during summer. So we bring in high mass and a lot of absorption capacity. Again, the building is naturally ventilated. We installed a wall heating system that you could also use for cooling. And again, we used timber flooring that is screwed, so you don't need to use glue. We have modern earthen plasters on the walls and also on the ceilings, and again, naturally ventilate the building. So last project I dashed through a little bit, we also scaled up this concept and brought it to a Flexim, or the building for Flexim is a big manufacturer of sensors, and they commissioned us to construct 12,000 square meter building. So far they have different departments, research and development, production, but also offices, marketing, whatsoever. And again, we applied our concept of low emitting materials with hygroscopic properties in order to be able to naturally ventilate the entire building. We haven't done measurements, unfortunately. This was the plan, but it never came through. But so the indoor environmental quality, from what we had as feedback from the client, works very well. But what would have been interesting is to measure emissions and also relative humidity levels, but unfortunately we didn't do this. This might be interesting because we didn't use earthen materials due to cost constraints, so we were able to also achieve naturally ventilation through the use of gypsum fiber boards. But as you can see here, we brought in a lot of timber because we had, due to the structural system, we had concrete timber ceiling, a hybrid construction, and in the main public areas, we tried to introduce timber. Floorings were specified or certified tiles or carpets in the office spaces. And this again is the last image of the boulevard, which shows you again the opportunity to naturally ventilate also the building during nighttime. And this should be it. Sorry, there was maybe a little bit of a rush towards the end, but I felt like the introduction for our way of thinking might be useful to understand in order to dive in a little bit more into our project. Thank you very much.
Thank you very much. All right. So now what's left to do is, of course, a question Q&A session. So all three speakers are still here to answer your questions, and we have two questions already in the chat, and I think I'm going to start with the most recent one because Andrea, I think it's directly directed to your presentation, and then we will work through other questions if they're going to be more. Also, everyone, please don't be afraid to raise your hands. Again, the reminder, you have to go on participants or Teilnehmer if you have a German interface, and then you can see the little hand button and you can raise your hand. So feel free to talk to us and speak to us. You can then also switch on your video so we can see you. We're always happy about these kinds of contributions. Okay, but chat questions first. So there's one question for you, Andrea. What do you mean with absorbing harmful substances? Won't they be released at some point?
That's a very good question, and I probably explained this not in depth. This is something we investigated. The earthen materials, they absorb harmful substances like the VOCs, as showed in the measurement, the specific that we spiked the air with. And we haven't tested it in detail, but the idea behind, or what we tested, is that they would be released again. So basically, if you open the window, this is the theory that we would have to prove, and you within the air of the room, you get a different sort of like climate, fresh air. You release also the VOCs of the earthen material, and they will be ventilated out of the room. The other sample that I presented, the wall build-up with this gypsum fiberboard, they don't release the VOCs again. So the theory behind there is that at some stage, when the buffer is sort of like exhausted, you would need to change the board.
Okay, thank you. And another question from the chat is, I think it was posted during Dr. Buschmann's presentation, rather at the beginning of this session, but it's not directed at anyone in particular, so speakers, feel free to just jump in if you feel the need to answer this. And the question is, how big of a contributor is formaldehyde in glues, wood products, insulation to poor indoor air quality?
I might say something, if, and I think Vanessa will be very good for that as well. Formaldehyde used to be a very big contributor to indoor air pollution, especially from fiberboards and from wooden glues in these wood chip products. Today, many manufacturers have been improving their products so that this is going down, and we have a strong kind of limit value now. If you look at the Blue Angel, and if you look at natureplus, of course. So there are products which are low emitting, but formaldehyde used to be a very big contributor. And it is additional to absorbing material. It was something which was tried to absorb formaldehyde. This was sheep wool, which was capable of kind of absorb it and bind it chemically. But this is something which is normally not, this is always an end of pipe of solution. So better is to provide products which are not emitting at all.
Mm-hmm. Vanessa, would you like to add something?
Yeah, it highly depends on the product, the contribution. So yes, there are many products which do not emit formaldehyde, but still chipboards do emit formaldehyde. And as Rolf Buschmann said, we have a limit value.
Okay.
Yeah, what else to say?
I think that there was a big study carried out by the Federal Institute for Environment and the Federal Institute for Material Research and Testing, BAM and UBA. They investigated these OSB boards in detail. And I think the result, Mr. Buschmann, you will know, was quite different. So there are really good boards out that don't contain much formaldehyde and range in the below the threshold level. But I think there were also a few products that were above the threshold level. So again, it's an argument for certified, specified products where you can be assured that everything is okay.
In addition, I can say I used to be doing testings in furniture many years ago. And one of the problems was that the glues, which you use for chipboards, in the production process, if you use glues which are not emitting formaldehyde in a bigger way, you have to have a longer pressing time on these boards. And this is something which is economic driving force for the producers not to do that. buy the cheaper formaldehyde emitting glues and reduce pressing time. So there are always possibilities to get low emitting products, but sometimes this is an economic feature which the producers have in mind and go for a lower economic driving point.
And one can add that wood naturally emits formaldehyde.
Yeah.
So we always see small amounts apart from the glues which are used.
All right. Okay, thank you very much. There is 2 more questions to Andrea Klinge. One is from Thomas Schmitz, and he would like to know, if you think about corona disease, the question of ventilation is crucial. Is it really better to trust on natural ventilation?
We believe yes. There's a statement out. We are in collaboration with a doctor from Switzerland, Dr. Walter Hugentobler. He did a lot of research. He's retired by now, but he did a lot of research on natural ventilation and the impact on building users, or the indoor environmental quality of buildings in buildings. And he did a statement, or he wrote a statement at the beginning of the corona disease, and he informed that it's very, very important to look at the relative humidity levels. And the challenge really is with mechanical ventilation, that if you over ventilate, it's really, really difficult to maintain 40%. I mean, the measurement I showed you was done in a winter that wasn't really cold. So, I mean, okay, winters are changing a little bit. We don't have minus 15 degrees any longer in Berlin, but we still have temperatures below 0. The winter when we measured wasn't really cold. So one can expect that if it's getting colder, the situation gets worse, because you drop down below 30%, sometimes 20%. If you naturally ventilate, you open the window for 5 minutes. Like if possible, you realize cross ventilation. So it's a very, very short ventilation process. And if you apply hygroscopic materials, the moisture generation through showering, through cooking, through being together in the room, you respire, or you inhale, exhale air. It's always sort of like moisture production. This will be absorbed by hygroscopic materials, and if the relative humidity level inside the place or the flat drops a little bit, the material will sort of like desorb the moisture out of the pores into the room again. That's why we achieve this 40 to 60% throughout the year. And it's not only us who did measurements. There are a lot of scientists out. Mr. Minke, he was a professor in Kassel. He did a lot of investigation on this topic as well. So yes, I believe totally naturally ventilation is very important.
I support this entirely, because you will find the comment of the Indoor Air Quality Commission on their website of the environmental agency. And you will know that in private rooms, in normal apartments, you will be fine with a daily opening the window and have a appropriate natural ventilation. So you don't need any mechanical things for that. It might be something which is useful if you have a big office building, but even there you might be faster and better if you open 2 windows on each side of the building and open it for 5 minutes in winter and maybe a bit longer in summertime to get a good exchange of the indoor air. And you will have a full exchange in about 5 to 10 minutes in this. And so this is enough. And if you do it twice or maybe 3 times a day, you are perfect. You don't need any mechanical or computer steered ventilation systems for that. Even though that these are have risks on their own, if you don't manage them properly, they can be a source for indoor air pollution as well. So this has to be monitored very, very, very careful.
Okay, and there's for now one last quick question to Andrea Klinge from Simon Corby, and he says, really interesting presentation, thank you, first of all, and would like to know if the H-House project has finished now, and where can we see more on the project, please?
Yeah, it's finished. Actually, it finished in 2017 already, so it ran from 2013. There's a project website, www.hhouse-project.eu. You should still find information. We published a few papers that should be on the website, those ones that are publicly available. I think there was one article in a German magazine, Wohnung und Gesundheit, that wasn't free of charge, so we couldn't upload this on the webpage. And you should find on our webpage as well a little bit of information. I think with the publications, we're not in good shape at the moment because we had a complete redesign of our webpage. So publications are probably better to find on the project website itself. But you feel free to drop me a line, and I'm happy to share information with you.
Would you repeat that first website you mentioned, because I'm happy to post the link into the chat.
www.hhouse-project.eu should be. Let me double check, not that.
Okay. H-House as in?
Sorry, H-house-project.
.de? All right.
EU.
EU.
For, for
yeah.
Europe.
Okay, I hope I got that right,
yeah.
but
that looks good.
I did my best.
Thank you.
All right, so there's a few more questions coming in. We are almost out of time, but I'm just gonna ask it anyway, so please maybe keep the answers nice and short. So Ilka Voss would like to know, do you think it makes sense to include testing of building products for emissions in the Bauordnung to promote the use of healthy building products? Vanessa Laumann, I think this question might be directed towards you.
Yeah, as I said, I'm not sure if Bauordnung means construction product regulation. I think so.
It doesn't say more in the question, sorry.
Yeah, so as I said, in the construction product regulation, the EU regulation, there's just a basic framework, and the aim or the goal is that the technical details for products are specified in harmonized technical specifications. And this is elaborated at the moment, but is still missing. So yes, it would be nice to have emission classes in the standards for CE marking. That would be the goal from my point of view.
All right, thank you. Okay, Tilman, what do you say? We're it's 5 o'clock, 5 p.m. So if anybody's interested, there is a bit of a discussion going on about the ventilation issue in the chat. So have a look at that maybe. But I think from our side, it might be time to wrap up this session. So Tilman, I'd like to hand over back to you for some concluding words.
Yes.
And yeah, from my side, thank you very much for the attention. I hope you enjoyed this web seminar. Yeah, so Tilman, over to you.
Thank you. Thank you very much, Katharina. Just to clarify what we talked before, so the declaration, the question from Ilka Voss. So we were talking about two things, I think. So the product declaration or regulations is something different than the Bauordnung. These are regulations of the German states itself. So, but I think in any case would be helpful to have more and clearer rules here regarding healthy building materials. Yeah, so first of all, thank you very much, Vanessa, Andrea, Rolf. Thank you very much for this very interesting presentation, for the overview and the technical details and the best practice examples. Also, I have to say thank you again for our two sponsors, Baumed and Lignodrent, because they really make it possible that we can offer these webinars and this professional level. And also thank you very much to our European partners, as mentioned before, EBO and ASPP, Acrodome and EOS. And you can get to know them better in the next events. So this time I try to go forward with the next slide by myself. Katharina, maybe. Sorry for that. Next slide, please.
All right.
And yeah, I could see many of you have already signed in for the next events coming in this event series. So if you haven't done this now, please feel free to join. We then will have more time to go more into detail regarding materials we use. Also, we were talking about regulations. For example, the next event that is really taking place on the 22 October, the web conference of Green Register and the ASPP, COVID-19, the importance of healthy buildings. There, for example, the Stefan Holgate, professor at the University of Southampton, he will give recommendations to governments. Also, John Palmer of the Passive House Trust will speak. So very interesting. We have more time there to go into more detail. You see it here due to Corona, actually, in the latest regulations there. Yeah, our on-site events, they won't take place. They will be postponed, and you will, if you have registered for them, you will receive from Acrodome, who's promoting these events, you will receive more information. So also having a look at the three other events. So you also can get to know better bio-based materials, really healthy bio-based materials from our Dutch partners, Acrodome, and the last web seminar on the 29th of October. There you also see again the interaction, the connection of different topics of sustainability, like healthy building on the one hand and circular economy on the other hand. So really interesting there. That's offered by our Austrian partner, the EBO. So yeah, feel free to join. And again, thank you all. Have a nice Feierabend, as we say in German. So have a nice after work time now, and see you next time.